In case anyone hasn't realised, Miles Davis is a lying sack of shit. Why is this important? Well, if he takes a video from the summit at 220 metres, we should see the hills higher than the bridge on a flat plane. On a globe, those hills should still appear lower than the bridge due to curvature. So, everyone, let's hop over to Miles' channel and demand that he take a video from the summit at 220 metres to see what a high camera angle will give us.
Hello and a very warm welcome to everybody once again. Today I want to respond to Flat Earth Perth, who you might gather from his name is a flat earther from Perth in Western Australia, I believe, not Perth in Scotland. A day or so ago, he published a video entitled Miles Davis Lying Again. And I'd like to play that video for you. It's only 2 minutes long, and listen to what he has to say, and then we can discuss exactly what he says and show that far from me lying, I can prove that I'm telling the truth and prove that he should now accept that the Earth is most definitely not flat.
In case anyone hasn't realised, Miles Davis is a lying sack of shit. And here he is at it again. The key to this one is that he claims the camera height is 210 metres, the same as the bridge. How convenient is that? Now, if you watched my last video about low camera angle, you should recognise the trick Miles was using. You see, if his camera height is, say, 209 metres, or just below the bridge height, guess what we would see? That's right, the hills would appear lower than the bridge due to low camera angle. Forget about asking Miles to prove he was at 210 metres, because there'll always be debate about that. A better approach is to use high camera angle. Miles shows us the monument at 220 metres elevation, roughly, I can't remember exactly what it was. Anyway, it's higher than the bridge, so it's a high camera angle. Why is this important? Well, if he takes a video from the summit at 220 metres, we should see the hills higher than the bridge on a flat plane. On a globe, those hills should still appear lower than the bridge due to curvature. Why is this important? Well, if he takes a video from the summit at 220 metres, we should see the hills higher than the bridge on a flat plane. On a globe, those hills should still appear lower than the bridge due to curvature. Why is this important? Well, if he takes a video from the summit at 220 metres, we should see the hills higher than the bridge on a flat plane. On a globe, those hills should still appear lower than the bridge due to curvature. So, everyone, let's hop over to Miles' channel and demand that he take a video from the summit at 220 metres to see what a high camera angle will give us. A video is better evidence than a photo, because with a photo, you can manipulate the f-stop number and make the background appear lower or higher depending on what you need. A video is better evidence. A video is better evidence than a photo, because with a photo, you can manipulate the f-stop number and make the background appear lower or higher depending on what you need. A video is better evidence. If he stupidly agrees to this, he'll prove to everyone what a lying sack of shit he really is, because we will see that the hills in the background will appear higher than the bridge. Game over, Flat Earth proved.
So there you have it. Flat Earth Perth says that if I can show a video taken from the top of Traprain Law, it should show the hills higher than the bridge towers. And if it does so, that would prove the flat Earth. Of course, the opposite is also true. If I show a video taken from the top of Traprain Law and it shows that the bridge towers are still taller than the hills from our point of view, then that would constitute a disproof of the flat Earth. Strangely, the first time I went to Traprain Law, I took a video from the top by the trig point. The visibility wasn't fantastic, but, well, you'll see what result I got. We should be focused at infinity now, and out there in the distance you can see the... So as I said, it's very windy, and it's probably better to narrate over it here because the original narration on that video wouldn't have been relevant to the video we're doing today. As you can see, the bridges there, and in the background the hills, albeit very hazy. We'll look at some still shots later that will make it clearer. But there's the bridges, and you can see clearly that the hills behind those bridges are lower than the bridge towers, exactly the same as from 210 meters, or very nearly exactly the same. Zoomed in a little bit here just to get a slightly closer up version. This was my first video taking of this particular view back at the end of October last year. In a moment or two, the camera will pan across towards Edinburgh and to the Pentland Hills south of Edinburgh, and then it'll pan back across and we'll see the trig point. And the reason, and at that point I cut the video because I don't think there's very much point in showing you the rest of it. It shows Fife and around towards the Bass Rock, which are not relevant to today's video. So that's Arthur's Seat, which is in Edinburgh, and as we pan a little bit further down round to the south here, we'll see the Pentland Hills. The camera's jumping around a little bit. I was just getting a feel for the lay of the land up there when I was taking this particular little video shot, and I must admit, given the weather was so good, I was disappointed at how hazy it was. So panning back across, and we'll go back past the trig point just to confirm that that's really where we are, and that's when the video, I'll just cut the video there because the rest of it isn't really very relevant to what we're doing today. So there's the bridges again clearly in shot, and then we'll pan back past the trig point here. So I hope you could all see in that video that the hills in the background are still below the top of the bridge tower, the central bridge tower, even though we are viewing them from 221 meters. It wasn't a very good day from a visibility point of view. It was a lovely clear blue sky, but there was a lot of haze at lower levels, and looking 90 kilometers into the distance, the hills were somewhat hazy. So what I've done here is to take a still shot from the video and put it into GIMP 2 photograph software and adjusted the level slightly so that we get a slightly clearer image of the hills in the background. You can see that if we put a line across the screen here, that the bridge towers are pretty level, and the north and south tower slightly lower than the central tower. They're 202 meters and the central tower is 210 meters. But they're the same distance below the line on each side. So this photograph is pretty level, and the hills are clearly falling below the line, even though we're viewing from 221 meters elevation. So here we have Cairnock Hill at 413 meters. Over here is Stron End at 511 meters. And here is Earl's Seat at 578 meters. You can just make out Nicol Bin here, which is because it's a little closer than Earl's Seat and it's 570 meters. does appear above the line. This was all explained in my original video. So we can perhaps zoom in a little bit on this just to see a little bit more clearly perhaps what we're looking at, and I think you'd agree that there is no doubt that even at 221 meters the hills are still level with or below the bridge tower height. Now there's a very simple explanation for this, which I will discuss very briefly now. So I don't want this to get too long or too complicated, but I thought I'd show a couple of diagrams and another picture just to explain what is going on and just why this observation of mine is completely impossible on a flat Earth. So this diagram is to represent a spherical Earth. We have a scale around the curve here, greatly exaggerated curve, but 90 kilometers. And the reason the curve is exaggerated is we used a very different scale on the vertical scale. This is only in meters. So the green triangle here represents Traprain Law, and the red line is the line of sight from 210 meters on Traprain Law past 210 meters for the bridge tower and on in the distance, and as we go past 90 kilometers we see that our line of sight takes us above 500 meters. This is exactly what we observe in reality. Now if I move my camera up to 221 meters at the top of Traprain Law, this makes very, very little difference to the observation that I make, and you've just seen that in the video that I've shown you. Moving the camera up 11 meters higher here only has the effect of dropping our line of sight to the hills in the distance by around about the same amount, and that's because the bridge tower is pretty much in the middle between Traprain Law and the hills in the distance. It's 46.5 kilometers from Traprain Law, and the hills in the distance are 90 to 100 kilometers away. So a small difference at Traprain Law makes only a small difference in the distance. And that's exactly what you've just seen in the videos and the still shots that I've shown. Now, the same thing applies on a flat Earth, but the nature of the observation should be very, very different. So if we look at a flat Earth diagram, so this is using the same scales as in the previous one, you can see that our line of sight from 210 meters across the top of the bridge tower should strike the hills at around 210 meters up. If I change my camera elevation to the top of Traprain Law, this will only have a small effect on the line of sight across the top of the bridge tower, and I should be able to see the bridge tower line up with something around 200 meters on the hills opposite. Now, Flat Earth Perth tried to claim that if I'd moved my camera, if my original shot had been from a little bit lower than 210 meters, that shot would be perfectly possible on a flat Earth. Well, how much lower would I have to go to get, let's say, Cairnock Hill, which is 413 meters, to get Cairnock Hill significantly below the height of the bridge tower in my line of sight? Well, I'd have had to go to sea level. And now I'd be looking above the bridge tower, or at the top of the bridge tower, lining up with something up at around 460 meters or so, if the Earth was flat. That's how low I would have had to have gone in order to be able to get that shot on a flat Earth. And even that wouldn't explain the hills that are over 500 meters and are still below the height of the bridge tower. It's simply not possible to get to sea level at Traprain Law. The base of Traprain Law is at 100 meters. In order to get to sea level, I would have to go to the coast to get down that low and to be able to still see the bridges and to be able to see the hills in the distance. So clearly I haven't faked anything, I haven't lied about anything in order to get the shot that I got originally. But it gets even worse than this particular case. I've published another video in which I was at the top of the Hopetoun Monument in East Lothian. Now this monument appears in the video that you've just looked at, and it also, by happy coincidence, is 210 meters above sea level, meaning that we are at the same level as the top of the bridge tower here in this picture. Once again, we see Kennock Hill below that level. Strong End here is below that level, even though it's 500 meters tall. Let's put in some of the hills. Meikle Bin is on the left here, and because it's a little bit closer and 570 meters above sea level, it does actually appear above the line. The same applies to Earl's Seat. We're a little bit closer than we were at Traprain Law, and so Earl's Seat appears just above the line, but nowhere near the extent that it ought to be. And the same with Dunbrack, which is next to Earl's Seat. Kennock Hill is still well below the line, 413 meters. And Strong End here at 511 meters, 8 kilometers further away than Kennock Hill, and that also appears below the line. Carletheron here at 485 meters. But now this is where it gets really good, Mr. Flat Earth Perth, because this is Ben Lomond, which is 974 meters tall and 116 kilometers away. And it is almost completely below the line. It doesn't get better. Ben Narnain is 926 meters tall. It's another 10 kilometers further away, and is all completely below the line. And the final piece that really nails this as an absolute proof that the Earth cannot possibly be flat is Ben Eam, 1011 meters above sea level at its peak. And although the peak of Ben Eam is slightly shrouded by the cloud, Ben Eam is completely below the line. All 1011 meters is below a line at an eye level at 210 meters. So, Mr. Flat Earth Perth, your very own words will now be repeated back to you, and I put it to you that you have no choice but to accept that the Earth is definitely not flat.
Why is this important? Well, if he takes a video from the summit at 220 meters, we should see the hills higher than the bridge on a flat plane. On a globe, those hills should still appear lower than the bridge due to curvature.
So, Mr. Flat Earth Perth, what do you say now? As I see it, you have only one honest response, and that is to accept that Earth is not flat. If you still have doubts about these absolute proofs that Earth is not flat, I would be happy to discuss them with you on a live stream on my channel anytime. Just get in touch and let me know. I'd also like to ask you to take down the videos on your channel that call me a liar, but that's up to you.